Hello, my name is Kareem El and my project is a prosthetic index finger operated by surface electromyography. I'm from Minnetonka, Minnesota, and my project ID is WHSENMB0056. So what is the problem that my research project is based around? The problem or question I kind of ran with is, can a prosthetic finger that is operated similarly to the original be built affordable enough that it can be widely available? For example, prosthetic fingers at the moment are usually mechanical or presentational, meaning they're just for show, they don't serve any function. Or they have prosthetics that are only good for one function, like a prosthetic that can write, like a pen prosthetic, etc. Um, and the robotic prosthetics are usually very expensive, super hard to get, and insurance doesn't cover them. And the goal of this project is to create a prosthetic that can be affordable and controlled like it was the original. So I read a number of research papers, but the one that really stuck out to me was this one on operation methods, not really the prosthetic finger itself, but how it can be controlled. And in the research paper, they created a prosthetic finger that could be controlled using surface electromyography, which is what I'm also having my finger be controlled with. But in this particular design, they didn't have it where you just had a 3D finger and electronics and you could be widely available. You have to have it surgically implanted into the knuckle bone of the amputee. And I took this idea, not really the mechanism, but the operation method. I took this idea and I tried to create it where the finger could be easily adjusted for different people and the electronics would be on the outside and it doesn't have to be surgically implanted. So it could easily be obtained and used without great surgery or setup or a bunch of steps to go through to get the prosthetic. So my method of research. The first step of my project, the first thing I did after reading and writing my proposal, the first thing I did was finding the area on the forearm where I got the most data from moving my index finger, because this is the point where the sensors are going to go to control the prosthetic. And in this picture on the right here is the sensor that I created. It had made of 2 circuit boards, one on the bottom, one on the top, that one of the LD bar, one of the EMG sensors that sense the movement, and the more data it receives, the more bars the LED lights. And this is on the area on the forum where I found was the most active spot. And on the left here was the second part of my project, which was to find a design for a 3D printable finger. Not design one, but to find one to save time to move on to the actual part of the project that is important. So I found this design right here and attempted to print it a number of times. The result slides where I'll go over this. So in the result slides, I found where the sensor must go for it to get all the feedback and activity to control the prosthetic. And I also found the design for the 3D printer, as you can see. And I also created a method of movement, or how the finger is going to curl, which is simply going to be a string run down the middle. If we go back to the slide, you can see there's a hole right here and a hole right there, which runs through the entire prosthetic. This will have a braided fishing line run through it, attached to the motor, and when the motor moves, it'll pull the fishing line and curl the finger. That's a method of movement I created based around this prosthetic that I found online. But progress has been halted because 3D printing a specific prosthetic, I ran into a couple problems with the 3D printing and the 3D printer itself. So after multiple prints on the Ultimaker 3D printer, they had a couple prints and they all turned out bad, but I corrected something on each one and they progressively got better. So the print one yielded absolutely no results. It did not print in the right material. It printed in PLA, and I'm trying to get it to print in nylon since it has living joints, and nylon is bendy and can bend without breaking. That didn't work. Spent a couple weeks trying to get the program to work itself. After winter break, I came back and the program had corrected itself, and now the extruder 2, which was nylon, was working, so I tried printing it again. And after printing it the second time, 5 minutes into the print, it fell apart, looking something like this, but a lot less material and a lot earlier in the print. And I realized then that's because most of my prosthetic was actually floating above the print plate. It wasn't actually touching it. So it was printing into air and it didn't cool enough to stay in shape, and it kind of just fell. So coming in print 3, I put more of the prosthetic down on the print plate and tried again. And this one took a little longer, but it ended up still falling apart because the prosthetic couldn't be laid 100% on the print plate. Because if we go back a couple slides, you can see that it has this area. And if you lay it down here, it still has this part above the print plate. So I tried it again, took a little longer, but it ended up with the same result, falling apart. Print 4, I learned from one of my classmates that if you printed it with supports, it should support the areas that aren't on the print plate and let it print fully. So I did this, added supports, let it print. 45 minutes into the print, it ended up looking like this right here. The supports were there, but it fell apart. After some looking into it, some research online, I realized that it could be that the printer is running really hot, and the nylon is printing at a really hot temperature, which doesn't allow enough time to cool before it falls apart like this. Because you can see areas that are structured and built here and here, and they're built, but they fall apart because the base is either didn't cool enough, so when you add more on top, it kind of just collapses. And so the next print, sorry, was to attempt to print it at a cooler temperature. But after trying to fix the pre-3D printer having it in a cooler temperature, I decided to attempt one more time with the supports, adding a little bit more and seeing what would happen. This hasn't happened yet, so I can't add it. The conclusions. So the 3D printing design that incorporates a living joint, which is a joint that doesn't have any moving parts, it's just a piece of plastic or something that bends. And the filament in the 3D printer, how it prints, might not be the best way for creating living joints and prosthetics with a lot of intricate designs inside and outside. So a resin 3D printer could work better since it's not taking away materials, kind of adding it hides more of the layers and can build intricacy easier. That might be a method of printing that I will look into. Another issue with the 3D printing is the project has not progressed far enough to see any successes, issues, or information regarded or gotten from the experiment, because the goal of the experiment was to try to make it affordable with surface electromyography, and I haven't reached the stage where I am testing the prosthetic with surface electromyography as of this moment. And these here are my references of research papers that I read and went through to come up with the idea for my project and things that people have already tried and succeeded at, it failed. Thank you very much for watching. Have a wonderful night.